Good morning, students. Today we are going to discuss mode of transfer of heat. Now there are three different modes of transfer: conduction, convection, and radiation, depending on the states of matter. Now we'll take uh, these three different modes one by one, and we'll try to discuss. Now the first mode of transfer of heat which we are going to discuss is your conduction. Now what is conduction? Let me try to define. As per the statement, it says that the process by which heat is transferred from the hot part to the cold part of a body through the transfer of energy from one particle to another particle of the body without the actual movement of the particles from their equilibrium position is called conduction. Now you see how it happens basically. Suppose if you have a metallic rod, and if you put one end of the rod to a source of higher temperature, so what happens? The heat will move from one end to another end, and other end becomes warmer. Now how it happens basically, when you put one end of the metallic rod to a source whose temperature is very high, and then the temperature of the source comes to the metallic rod, and the particle starts vibrating with higher energy. Now this vibration basically about the mean position of the particle. Now when it vibrates, it disturbs the neighboring particles, and the energy of the neighboring particles also increases, and that particle also starts vibrating, disturbing its neighboring particles. So in this way, due to the vibration, the energy transfer occur from particle to particle, and ultimately the other end of the metallic rod becomes warmer. Now here basically the energy transfers from particle to particle without actual movement of the particles, and the process is known as conduction. Basically in case of solid, we wish to get this mode of transfer of heat, conduction. Now based on this mode of transfer, there is a special topic that is your thermal conductivity, because there are many materials which conduct heat, and some materials are there which does not conduct heat. So basically we'll consider the metal basically who have where transfer of heat occurs from one part of the body to another part. So please go through this definition. It's a very simple. Here the mode of transfer of heat occur from one end to the another end without actual movement of the particles. Now in thermal conductivity, we'll consider this figure. You see this is a block. It has 6 phases. Now what we'll do, we'll consider two phase 1 and phase 2, opposite phases. Now the distance between the two phases is your delta x. Now two phase is of different temperature. Phase 1 is of higher temperature, that we have specified theta plus delta theta, and phase 2 is of temperature theta. So what will happen? Heat will transfer from higher temperature to lower temperature. Now we are going to define the parameter on which the flow of heat depends. Now basically the symbol for heat is your Q. So basically the heat Q flow from phase 1 to phase 2 depends on, number 1, directly proportional to phase area. If the area is more amount of heat will transfer, because area means area high means amount of particle available on that specific area is also high. So more the particles, more amount of heat will transfer. So directly proportional to area, that is your capital A, phase area. Phase 1 and phase 2 have area capital A. Now inversely proportional to distance delta x. So definitely if the distance is high, less amount of heat will move from one phase to another phase. That's why inversely proportional. And directly proportional to time. If you perform your experiment for longer time, then definitely more amount of heat will flow, and the flow will continue till the equilibrium is reached. Once the equilibrium is reached, no flow of heat will occur. And lastly, directly proportional to the difference in temperature. If the difference is high, the difference in temperature is high, more amount of heat will flow from phase 1 to phase 2. So these are the parameters on which the amount of heat flow depends. So combining this parameter, we can define one expression, that is Q proportional to A for area, T for time, delta theta for difference in temperature, and delta X is your distance between the two phases. Now to remove this proportional sign, we have to bring one constant, that is your constant is your K. K is your constant of proportionality, known as thermal conductivity, and delta theta, delta X basically known as temperature gradient. And we are including this negative sign with delta theta, delta X, and the negative sign shows that decrease in temperature with distance. So if a distance is high, fall in temperature will be more. Okay, negative sign shows decrease in temperature with distance. So if distance is high, fall in temperature will be more, or you can say decrease in temperature will be more. So if you define K, then you have to bring K in one side and rest of the terms in another side. So K equal to Q divided AT minus del theta del X. Now if we consider this parameter, if A equal to 1 meter square, because A is your area, del theta equal to 1 degree centigrade or 1 Kelvin. Delta theta is nothing but the difference in temperature between the two phases as per the diagram, and delta X is your 1 meter distance between the two phases. And if we consider T equal to 1 second, then K equal to Q numerically, because negative sign will be there, but we are considering the magnitude, that's why K equal to Q. So you can define thermal conductivity, that is thermal conductivity of a material is defined as the quantity of heat that flows across the opposite phases of a 1 meter cube in 1 second, when the opposite phases of the cube are maintained at a temperature difference of 1 degree centigrade or 1 Kelvin. So it's very simple. If you consider this diagram, this definition is very simple. Now thermal conductivity, which we have specified with the symbol capital K, have its unit as well as dimension. So if we consider CGS system, Q is your calorie, T is your second, so calorie per second, and delta X centimeter, A centimeter square. So 1 centimeter goes up per centimeter per degree centigrade. So in MK system, unit of K is again joule per second per meter per degree Kelvin. And the dimension, again you try to find out the dimension. You all know all the parameter with the dimension, because Q is your heat is some kind of energy, so put the dimension for energy, and delta theta here, temperature we specified Kelvin, that is your K. So ultimately the final expression for the dimension is your M1 L1 T minus 3 K minus 1. So try to find out the dimension by yourself and check it correctly. Now the next mode of transfer is your convection. Basically this mode comes when the state is your liquid or gas. Now here the flow of heat will occur from one region to another region with the actual movement of the particles. So let me define the process of heat transfer from one part of a fluid to another part by the actual movement of the particles of the fluid is called convection. So you can consider movement of air, movement of liquid. If you prepare tea, the tea leaves moves from one end of the region to another by the actual movement of the liquid particles. So basically fluid shows this kind of mode of transfer of heat, which we define as convection. Here the actual movement of the particles occur from their position, and in case of conduction there is no movement of particle from the equilibrium position. only the vibration occurs, and this vibration transfers the heat from one end to the another end in conduction basically. Now next part is your radiation. Radiation basically we'll consider the sun rays. The process of transfer of heat from one place to another place without heating the intervening medium is called radiation. So this is possible only in case of sun. Without heating the intervening medium is called radiation. So these are the different modes of transfer of heat. So please go through and try to check out the topic by taking one textbook or reference book if you have. So please go through and put your doubt. Thank you.